Okay, welcome back. This is question 49 from chemistry section in IMAT 2016 past paper. So I will be explaining this question. So it says how many unbranched straight chain molecules are there with molecular formula C₄H₈F₂ but with different structural formulas. So we know that this question is related to isomers. Isomers. Okay, so we must recall the most basic definition about isomers. So isomers are those with same molecular formulas, molecular formula, but differ in structural arrangement. Okay, so basically they all have same molecular formula, but they differ in the connectivity, which is the structural arrangement. Okay, so some can be branched, some can be straight chain or anything, but they must have the same formula, which we are given with 4 carbons, 8 hydrogen, and 2 fluorine molecules or atoms. Okay, but the most important point, we must know that the question explicitly mentions unbranched straight chain molecules. So what this refers to more specifically is that it refers to a carbon. So we are given with 4 carbon. So this means it must remain this as linear chain throughout different structural arrangements. So which what is that atom that causes different structural arrangements? So that is the fluorine atom that will differ in structural arrangement while keeping a linear structure of a carbon, but they have same chemical formula. So that we must keep in mind that what the question is trying to ask. So let's proceed to make the skeletal diagram for each different kinds of structural isomers that corresponds to same formula. Okay, so let's begin. So I'm going to draw a skeletal formula because that's very easy and very quick, because we know that IMAT is only of 90 minutes and it's very time limited. So rather than drawing like a displayed formula like this and then drawing H and then H, it's going to like take a lot of time. Okay, so I'm going to straight away draw and also encourage you people, students, to draw a skeletal diagram to save the time. Okay, so this will be the first structural isomer. So this is a straight chain that you have to keep in mind. But the only thing we're going to change the connectivity is the fluorine atom in this straight chain molecule, the carbon. Okay, so I'm going to randomly place. So let's start with here. I'm going to draw 2 fluorine this side and 2 fluorine this side. Okay, so this will be 2,3 difluorobutane. Okay, so it's butane because there are 4 carbons. So it's butane, and we have 2 fluorine molecules, so it's difluoro. And always remember about the IUPAC rule. The most important we must follow here is that we always count from the smallest count as possible. Like here, 1, 2, 3. But you might not find any much difference because you can even count from here and get the same results. But as we move forward, you're going to find the major difference as to why this rule is very important and how it's named. But for this question, you don't really need to know the names, but still it's important for understanding. Okay, and then the second one, and keep in mind we have to keep the carbon chain a linear chain, no branching. Like for example, I draw like this, and then I draw this branching over here. I have like methyl groups over here, so this is completely wrong because it says unbranched. Okay, it must be a linear chain. Okay, so now the other side I can draw fluorine over here, 2 fluorine in one side. Okay, so its name will be 1,1 difluorobutane. Okay, and number 3, I'm going to draw on the different sides. Okay, so fluorine over here and fluorine on that side. Okay, so this is going to be 1,3-difluorobutane. Okay, so as I was saying, that the most important IUPAC rule you must know is that always count from the smallest possible side to have the smallest count. That's the rule. For example, I start from here 1, 2, 3, 4. Then I name it as 1, then I name it as 2, 4 difluorobutane. That is completely wrong. You have to start from the smallest count as possible. So that is, I'm starting from here 1, 2, 3. So that will result me in the smallest count. So this is the most important IUPAC rule that you must keep in your mind when drawing the structural formula for any compounds, any organic compounds. Okay, and number 4, the structure is going to be like this. One fluorine here, the other one over here. Okay, so the name of this will be 1, 2, as I said, count from the smallest side, not from this side, 1, 2. So 1, 2 difluorobutane. Okay, so now the fifth one. Okay, so the fifth one is going to be over here. Going to draw 2 fluorine atoms over here. Just as I draw 2 fluorine in the first carbon, now it's going to be in the second carbon, 2 fluorine together. So this will be 2,2 difluorobutane. And then the number 6, I'm going to draw as this way, and the other ends of the carbon chain. Okay, so it's going to be 1,4 difluorobutane. Okay, so that's the maximum possible structure formulas that we can draw and construct, all same corresponding to the same chemical formula: 4 carbons, 8 hydrogens, and 2 fluorine atoms. Okay, so this is the maximum possibly we can draw. Okay, so we have total 6 structural isomers with same chemical formula. Okay, so the correct option is option E, 6 unbranched straight chain molecule with this chemical formula, C₄H₈ and F₂. Okay, so that's how we solve this question. It's pretty straightforward and the easiest one. Okay, so thank you guys for watching my video. I hope you find it helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.